Everyone, welcome back. Welcome back to another new week of remote classes here. So today we are going to extend our discussion forward from where we left last time. So today we are going to talk about some additional information on file-based operations. So in the last lecture, we talked about how to connect to a file, and then later how to display the file contents. So if you have not done so already, I ask that you again go back and watch the previous video, so as to refresh your understanding on file based operations. So if you recall, the last time we ended the session by asking a series of questions, and I had reviewed all your reflection document last time. I should say that it was quite interesting to see all your different ideas and how to go about implementing these operations on the files, right? So if you recall, we talked about adding a plant, deleting a plant, and then updating a plant. And then we also talked about doing some analysis on that data file, where we would ask a series of questions on that plant data. For example, question one would be show the plants that are priced less than $5. Question two would be show the plants that require sunlight. And then question three was we wanted to show the plants that are of the planting zone 3. So one can ask a series of questions like this on a text file, what we often call as text file analysis or performing string based operations. So before we get to implement these three analysis modules, let's call it that way, let us briefly look at how to perform this operation. So I'm going to open up the plant.txt file, which is available for you in the data folder. So if you look at the file, there is a input tag called price, and then there is a dollar amount, and then there is a price that is ending right here. So this is what we call as a structured data. So the data is in a sense more structured, so we can trust the format of the data. So all we are looking to do is we are looking to um, parse the string and then extract the information between the price start tag and price end tag, right? So that's going to be the price amount or the price, which we will then store it into a double, and later we can compare that to see if it was less than $5. Okay, so before we get to see how to actually implement this, I like to run a simple example here with you guys. So let's say that we have a text here called string text. I am a CS 101 student. So in strings there is a particular method in Java called substrings. The substring simply take two inputs, right? So the first input is going to be a number that we would start the substring from, and then second input is going to be a number that we will end the substring at, right? So meaning if I would have, let's say, Bob, um, Peter, let us say, and then if I would do a substring of 2, or let's say for this matter 4, I'm counting the position number here, as you can see 0 1 2 3 4. 4 is where the P would start, and then 5 6 7 8. If I would do 4 comma 8, then I will simply get Peter, right? So Peter, I'm counting from capital B, 0 1 2 3 P is 4, and then E5, T is 6, 7, and 8. So I get Peter as the output of that substring function, right? So again, we are using that substring here in this example to retrieve CS101. And then you can see that instead of giving the hard-coded number, we could also use what we call as index of. So index of is another function that's related to strings that takes in an input. I am it takes in an input string, and then it will automatically calculate the position number of that first character in that string. And then I will simply add, in this case I'm adding 7 to it because I know that the string here is 1, 2, 3, 4, 5, 6. 6 plus 1 would be 7, so I'm adding 7 so as to make sure that I can retrieve from the capital C. So capital C would be the starting point for my output. And then you can also see here we are doing a text.index of student. Again, student, the index of function would return the position of that first character, which is the small s or the lowercase s. And then I would simply do -1 so as to make sure that I would stop at this particular one right here, right? So when you print this, I recommend that highly you go and do this code yourself on your machines and then understand how the substring works. So if we would print the course number, we're supposed to get CS101, right? So then later you could again apply a substring. This time, once you get CS101, I'm going to open up a new tab here. So I have CS101. I am going to do a substring 0, 1, 2, 3, which would start after the hyphen here. So I'm going to do 3, comma, and then the length of that string, right? So which will then go until 101, right? So you can see we did that here, 3 comma course number dot length, which is simply the length of the string, and then you will get the substring, which is just 101, right? Clearly you're stripping off the CS hyphen from that and getting just the number of that course. And then once you get the number, you can convert that into a double if you would like by using double.parseDouble and then passing that number, which was a string. Or you can also do integer.parseInt if you want to convert the string into an integer. So necessarily we are converting a string to a double, and we are also doing the similar process here where we convert a string into an integer. We can also do that, right? And then later I simply print that, as you can see. So I'm printing the string version of the course number, double version of the course number, and then the integer version. All right, so I like to run this program here. Let me quickly compile and run this string utility. So you can see now, firstly, we extracted CS hyphen 101 from our input string. I am a CS 101 student, right? And then later we were saying that, okay, from CS 101, can we just extract the number of that course, and then we turn that into a double, we turn that into an integer. Okay, so if we would change this, now you can see, if I would change this CS202, right, and I didn't do any other change to my code, right? So automatically this would work if I would simply compile this program and rerun it. So you can see now it's referencing to CS202, and then 202 is printed, double and integer version is printed. So that's the beauty of this code, is that if we would apply substring string and index of and length functions with the string, then clearly we can do a lot of string parsing. So with that understanding, I like to go back to our plant driver.java. And again, this code is provided to you in our repository that will be shared with you in a minute here. So you can see that a series of changes have been made to our original code from last time. So I added a scanner, and then I added a list of inputs, and I added a string input in line number 6 with 6 inputs. It's an array of strings. And then you have the file utility, and later you're creating a plant, and these are all part of the previous code, but the line number 11 to 13 is added in this particular code. So as you can see, we're calling Q1, Q2, and Q3, and Q1, Q2, and Q3 are the solution to those questions that we had asked earlier. Okay, so at this point, I like to go into the plant.java file and go over Q1, Q2, and Q3. Look, for Q1, we had already parsed the file, and then we had stored it in an array of strings, list of plants. So we simply loop through that by running our for loop, and then you can see like what we did with our string utility example. We are using a substring, and we are using index of to extract the price, and then we are using a parse double to convert that string to a double. And then later we are validating if it is less than 5.0, then we simply print the plant name and its price. And again, I'm using substring, index of, and the price which we had already extracted. The reason we are converting the string to double is because we like to do a comparison later on, which is on line number 84. Every time we need to do a comparison, keep that in mind. We cannot do that with a string. It got to come back to a double variable type so as to make sure that we can do any comparison like less than, greater than, and so on. So that's for Q1, and Q2 is again quite similar to Q1. If you would follow Q1, then Q2 should be even more straightforward. Simply we are extracting the characters between the start light tag and then the end light, and then we are using substring here again, and here we check if it contains sunny or it contains sun or shade, then we simply print that. You can see that we are doing a substring, and then we are printing if it is sunny or sun or shade, we print that light along with the plant name. And that's what we wanted to do for Q2. Is Q2 we said we wanted to print all the plants that needs sunlight. Q3 is where we are using a zone. So the data, if you look at the data, although it is a structured data, one needs to understand the data very well so as to make sure that your program works correctly for all the cases outlined in the data. So if you see, if I would do a 3-5, then I get this as zone, and then I also have annual as a zone as well. So zone is not always a number. It could be annual, or it could be 3 to 5, right? So we need to catch those special cases, and that's what we are doing in Q3. We check if zone string contains annual and 3 to 5, then we simply ignore that. If it doesn't contain that, as we are using a not operator, then we do a parse end, and we parse that string input into an integer. And why would we do that? Again, we like to do the comparison. Remember, we said anytime we want to do a comparison like double equal to, we want to make sure that we convert that into an integer or a double version. In this case, it is an integer. So we check if it is double equal to 3, we simply print the plant name and the zone number. So that's Q3, right? So I like to go back to plant driver again, and then you can see Q1, Q2, and Q3 are fully implemented. And I like to, at this point, go back and compile and run this program here. So I'm going to compile and run this program on my machine. And you can see when you compile and run it at your end, firstly, all the plans are displayed. Then Q1, which is the price of the plan for less than $5. So all the plans would be displayed here. And then plants that need sunlight, Q2, would be displayed. And finally, plants that are in zone 3 would be displayed. Okay, so that's the implementation for Q1, Q2, and Q3. And I should point out that this particular implementation is something that we are doing for 101 class. The data file was originally available to us, and all these implementation are specially implemented for our 101 class, right? So please keep that in mind that for any data file, we would be able to follow a similar logic and similar implementation style so as to make sure that we are addressing the questions that is related to that particular file, right? So for this file, we specially made this for 101. I implemented this Q1, Q2, and Q3 just for this plant file, which is for 101 class, right? But then later, let's say if you have a food menu.txt, right? And then you can implement a series of questions related to that food menu.txt. Or as well as you can implement Q4, Q5, Q6 on this plant.txt. If you are interested to implement any further questions, you should be able to do that as well, right? Okay, so I like to go back to the plant driver, and let's uncomment this line here, line 16, where we want to add a new plant, and I am going to add that comment right here in that 36, 37. I would like to add that comment, multi-line comment there. So let's test the add plant. If you remember, we wanted to add a new plant. So really, we get a series of inputs from the user for the common name, botanical name, zone, so on and so forth. And then we add that to that input array, and we pass that input array to our add new plant method, which is available in plant.java. So let's go over that add new plant method. You can see right here. Again, we are doing an update. We update the last line to be a new plant, and then we write to the file the series of inputs. Again, the write and update process was discussed in my previous video clip. So if you have not done so, I recommend that you again go back and watch that. And later, we will simply say that a plant has been added successfully, right? So that's the add plant method. Can we test this at this point? I like to go back and then clear my screen, and then I'm going to compile and execute my program. So you would compile using Java-C and then Java to compile and execute your program, as you often do, right? So I had already opened the plant.txt here. So you can see the last plant was cardinal flower. So I'm going to add a new plant. Let me call this common 1, and then button 1, and zone I'm going to keep that as 1. Light I'm going to make it sunny. Price says, let's say 10.08, availability, let's say 1, 2, 3, 4, 5. So it says plant added successfully. So if we go back, and now if we look at the text file, you could clearly see that a new plant has been added, right? Common 1 has been added as the lost plant in that list, right? So I'm going to leave this as it is and then go back to our plant driver, and let us also discuss how to delete a plant. So I like to uncomment that line and then add a comment after this delete here, right? So at this point, we should be able to see if we can delete a plant. So let's firstly we get the user input to ask the user which plant to be deleted, and then we call the delete plant. Keep in mind we are passing the util as we did for our display plants, so I'm not going to repeat that again. We talked about it when we looked at display plants. So we pass the util input, and that's the key, right? So now I like to go to the util or the delete plant function. So you can see util.size gives us the size of the file in terms of the number of lines, and then we run a for loop. We read line by line. We read line by line and check if line.contains plant name. Simply we update. We keep a count actually right here. Every time that you don't find the plant name, the count will be updated so as to make sure that we know which line we are currently in. Then you use that count and you're updating the common. Count plus 1 would be for the next line, and next line would be plus 2, so on and so forth. You update all the subsequent lines with the empty tag, which means then the data is deleted in this case. And then finally, you're resetting your util so that the next time when you're doing a read, it reads from the first line. And we also set a flag. If the flag is true, which we set right here in line number 57, then we simply say that the plant is deleted. Else, the plant was not found, right? So there's no plant found in that case. Okay, so at this point, I like to save this program and let me try to recompile and execute this program. So now it's asking me for a common name again. I'm going to do common 2, and then I'm going to do a button 2. Plant zone, let me do a zone 2 this time, and I'm going to do sunny again, and then price, I'm going to make it 5.45, availability, let's say 3214. It's prompting me to saying that the plant was added successfully, and I like to delete the common 1. Okay, so I type in the plant to be deleted as common 1, and then I hit enter. It says plant deleted successfully. Okay, so I like to go back to my text file, and here you can see that common 1, which we added previously, is now empty, which means then that plant has been deleted, and then a new plant, common 2, was added in this case, right? Alright, so that's the summary of our discussion here for the implementation of add and delete plant. So at this point, I like you to go ahead and uncomment this line and uncomment the line towards the end here. And I like to go over the technical details here in this code. So this particular section is asking the user to tell us the plant to be updated, and then we ask a series of questions like what we did for the insert or add a new plant. This time we ask them the new plant common name, new plant technical name or botanical name, zone, site requirement, price, and so on. And then we construct the input, and later we call the update plan with the input that's provided here. And then the method is added here. So I like you all to work on the implementation of this update plan. And again, it should be similar to what we did for delete plant. So please make sure that you add that implementation and then you work on that individually. And please make sure that you do the commit and push by 5 p.m. today, Eastern Time, so as to make sure that I can provide you with the class participation credits. And if there are any questions, please don't hesitate to ask me in Slack, or you can email, and as well as send me a note to be discussing during the virtual office hours. So I know that the lab would be due tomorrow. This is a quick reminder. If anyone has a question related to the lab, you please ask me in Slack or email. We could also plan to do a quick Google Meet if you would like to do it that way, right? All right. Well, thank you for watching this video.